Alright, so in 5.3 we are solving trig equations. So just like when solving an algebraic equation, our goal is to isolate the trig function. So we want to get that trig function all by itself on one side of the equation. So what would we do here to get that sine of x all by itself?
Just add the 1 to the other side.
Add the 1 to the other side, so just like algebra. Then we have 2 sine of x is equal to 1. What do we do next?
Divide by 2.
Divide by 2. So sine of x is equal to 1/2. Now, this is where it changes a little bit from algebra, and we just have to add one extra step here. So if we remember back when we were dealing with our trig functions and we had x, y, and r, what is our sine function? So if we had the coordinate point x, y, what is sine?
Y over x.
It would be y over r, but our r is just 1, so our sine is just the y. So our sine value is the y value. So now we go to our unit circle and we look for all of our y values that are 1/2 because sine of x is equal to 1/2. So this is what we look for in the y value on our unit circle. So where do we see y as 1/2 on our unit circle? At 30 degrees, which is pi over 6. So we're just looking at the radians for now. Pi over 6. And where else?
The 5 pi over 6.
5 pi over 6. So our answer here would be x is equal to pi over 6, and x is equal to 5 pi over 6. So we had sine of x is equal to 1/2. That 1/2 refers to our y value. So we look on our unit circle to where y is 1/2. So we have y is 1/2 here and y is 1/2 here. So we're looking at the radians of where sine is 1/2. That y is 1/2. Any questions? All right. Sometimes we have to combine our like terms. So here we have more than one sine, just like in an equation where we would have more than one x. We've got to combine our like terms together. So what do we do first to solve this? How do we combine our sines?
Can you add the sine of x
Awesome.
to the other side?
Add the sine of x to move it to the other side. So what's sine of x plus sine of x?
2 sine of x.
2 sine of x plus square root 2 is equal to 0. What can we do next? What?
You add the square root.
Subtract the square root. Anna, what did you need?
No, I said unit circle now.
Not yet, because we want that sine of x all by itself before we go to the unit circle. So we subtract the square root 2. So we have 2 sine of x is equal to negative square root 2. And now what?
Divide by 2.
Divide by 2. So sine of x is equal to negative square root 2 over 2. Now that we have the sine all by itself is when we go to the unit circle. So if we have sine, which value are we looking at, the x or the y? The y. So again, we are looking at the y values on our unit circle. So where on our unit circle is our y value negative square root 2 over 2?
5 over 4.
5
and
pi over 4
Pi over 4.
and 7 pi over 4. Awesome. So we have 5 pi over 4 and x is equal to 7 pi over 4. Example 3. Here we have tangent. So 3 tangent squared x minus 1. What should we do first to get that tangent all by itself?
Add the 1.
Add the 1. So 3 tangent squared is equal to 1. What's next?
Divided by 3.
Divide by 3. So tangent squared x is equal to 1 over 3. What's next?
Square root it.
Square root it to get rid of that squared. So tangent of x is equal to, what is the square root of 1? 1. And then the square root of 3. What's that one thing we can't forget when we take the square root of both sides? Plus or minus. And then just like before, we can't have a square root in the denominator, so we have to rationalize. So what can we do to get rid of that square root from the denominator? Right. Multiply the top and the bottom by square root 3. So we get plus or minus square root 3 over 3. Now tangent is the one that's a little bit trickier because we know sine is y, cosine is x. Tangent is what?
It's both? Or no, it's, yeah, right? Or am
Tangent.
I wrong?
Tangent is y over x.
Yeah, so it's both x and y, or y over x.
Y over x. So we need to now take our x's and y's and put y over x and figure out which one is a positive square root 3 over 3 and a negative square root 3 over 3. So to do this, we want to look at the first quadrant. We have tangent, we said, was y over x, so we're going to put our y value over our x value. So here we have 1/2 over square root 3 over 2. What happens when you have a fraction inside a fraction?
You do the reciprocal?
Keep, change, flip. So we have 2 over 2 square root 3. The 2's cancel, so 1 over square root 3, which when we rationalize, what do we get? Square root 3 over 3. So is this what we needed for tangent?
Yes.
Yep, it's one of the positive ones. So pi over 6 is going to be one of our answers. Let's try pi over 4. So we have square root 2 over 2. What's square root 2 over square root 2 over 2 going to be?
1.
1, because it's the same thing over itself. So this is just 1. So that doesn't work, and let's try the top one. So we have square root 3 over 2 over 1/2. Keep, change, flip. So this would be square root 3. The first quadrant here, so we're only going to test these, which is super helpful if you memorize these, but you also can use your notes on tests and quizzes, so have these written down in your notes because these values will never change. So anytime you're using tangent, the pi over 3 is going to be square root 3. The pi over 4 is 1, and the pi over 6 is square root 3 over 3. Now, in our other quadrants, they're the same values, but the signs are going to change. So over here, this is going to be negative square root 3 over 3, negative 1, and negative square root 3. Down here, we have another positive square root 3 over 3, positive 1, and positive square root 3. And then on the fourth quadrant, it's negative again. So this would be square root 3, 1. The first one is square root 3 over 3, 1, and square root 3. So all you need to know is the first quadrant, and then all the other ones repeat. So we're looking for a positive or negative square root 3 over 3. So what are values for x? So we said pi over 6 works. Where else do we have a positive or negative square root 3 over 3?
7 pi over 6.
7 pi over 6. Where else? So we got this one, we got this one. Remember, we're looking at the
11 pi over
11 pi over 6. Right, but we're looking at the positive or negative. Oh yeah, these are negative. But our x's can be positive or negative, so we need them both. So we're going to have 4 answers. We have 1 left. Where else do we have a positive or negative square root 3 over 3? 5 pi over 6. Good job. So we have 4 answers here. So the tangent one's just a little bit trickier because you actually have to do the y over x, but once you do it once, it's always going to be these 3 numbers. And then the way I think about it is that like the numbers closest to the x-axis, so like this one, and this one, and this one are all the same. It's just the sign that changes, but you can always see this has 1 negative, so your answer is going to be negative. This, a negative divided by a negative, is going to make a positive. This one of them's negative, so your answer is going to be negative. So an easy way just to look at the signs and see. Any questions on this one?
Remember that.
All you need to do is remember this. So just remember these 3. Remember this part, the first quadrant, and then you're good. So just remember these 3. And the rest of them are the same. So you don't even have to work it out every time. Now that you know it, have this in front of you. If you forget it, then you can work it out. Alright, let's look at number 4. Any other questions on that one? Alright, number 4. So here we got some different trig functions in our equation. So what should we do?
You should convert it, so cosine over sine. No.
We can do that, or let's see. Why don't we move everything to one side and then see what happens? Because it tells us we're going to factor, so when we're factoring, we want it to be equal to 0. So let's move our two cotangent x over. So how do we move that over?
Just subtract the 2 cotangent x.
Right? So on the left side, we have cotangent x cosine squared x minus 2 cotangent x is equal to 0. if this looked like a regular algebra problem and we had, let's say, x times y squared minus 2x is equal to 0, how would we factor this? Take out the x. So what can we take out here? Take out a cotangent. So cotangent of x, and then cosine squared x minus what? Minus 2. Okay, so back to our regular algebra problem. We took out an x. So we have y squared minus 2 is equal to 0. How would we solve this now? Break them up and solve them separately. Perfect. It doesn't really make any sense with a y, but I'm glad you noticed anyways. So we break them up. So we have cotangent x is equal to 0, and cosine squared x minus 2 is equal to 0. So now we just have two separate problems. So cotangent x is equal to 0 is already solved for us. We don't have to do anything to get our trig function all by itself. In terms of x and y, what is cotangent? X over y. And if x over y has to be 0, because 0 is what we're looking for, what does that tell us our x over y has to be?
0.
Which one has to be 0?
X.
The x. The x has to be 0 because if 0 is on top of the numerator, on top of the fraction, the whole thing's 0. So x has to be 0. So let's go to our unit circle. Where is x 0?
At pi. Never mind.
Pi over 2, and where else?
3 pi over 2.
3 pi over 2. So we have x is equal to pi over 2, and x is equal to 3 pi over 2. So now let's do our cosine squared minus 2. How do we get cosine all by itself?
Plus 2.
Add 2, so cosine squared x is equal to 2, and square root. So cosine x is equal to, what do we have to remember when we take the square root of both sides? Plus or minus square root of 2. So we need to look for the square root of 2. What's cosine? What are we looking at when we have cosine?
X over r.
Or just x. So cosine is x. So looking at our unit circle, where is x a positive or negative square root 2? Do you see it anywhere?
Isn't it at the 360 mark? Oh, never mind.
We're looking, where is x a positive or negative square root 2? Nowhere. So it does not exist on the unit circle. So it doesn't count as one of our answers. So our only two answers are x is equal to pi over 2 and 3 pi over 2. So this is not on the unit circle. So we can get rid of it. Ignore it.